Okay, let's do the confidence interval classwork now. We're going to work through 6 problems. And what do you want open? You're going to want the classwork itself open, the Word document here. It's called 292 CI practice. And you're going to want a mini-tab file open. You can certainly have a blank one. There is no data file for this practice. I just have the original lecture mini tab still open that I'm going to work from, but you certainly don't need to. All right, let's start working on these. Number 1, a telecommunications company wants to estimate the mean length of time in minutes that 18 to 24-year-olds spend text messaging each day. In a random sample of 27 18 to 24-year-olds, the mean length of time spent text messaging was 29 minutes. From past studies, the company assumes that the standard deviation is 4.5 minutes, and the population of times is normally distributed. Construct and interpret a 99% confidence interval. All right, so we know it's a confidence interval. We know it's about the mean because we read mean and we are given a standard deviation. So we know it's going to be Z or T. The question is it going to be Z or is it going to be T? And we've got some key words here. From past studies, the company assumes the standard deviation is 4.5. This is going to be Z, all right, because we are given this old historical standard deviation, all right? It's not coming from the sample. All right, so we go into one sample Z. We choose summarize data. Our sample size is, you got to be careful, it's typed out. We have 27 18 to 24-year-olds. The mean was 29 minutes. The known standard deviation is 4.5. And we go under options and change our confidence to 99%. All right, there's our confidence interval. Now we just need to interpret it. So we say with 99% confidence, we can say the mean time spent text messaging for all 18 to 24-year-olds is between 26.77 minutes and 31.23 minutes. All right, now here's a question for you. What if I came back and I said to you, aha, we found this infographic online that claims that teens are spending 45 minutes a day text messaging. Do your results support or contradict that 45-minute claim? And the answer is, your answer contradicts it because your answer says the average time is between 26.77 and 31.23 minutes. So in other words, when I ask you a question like that about a claimed number, you're just looking to see, is that claimed number in the interval, in which case your interval supports, or is that claimed number outside the interval, in which case your interval contradicts? Okay? All right, number 2. A cheese processing company wants to estimate the mean cholesterol content of all 1-ounce servings of cheese. The estimate must be within 0.5 milligrams of the population mean. Determine the minimum required sample size to construct a 95% confidence interval for the population mean. Assume the population standard deviation is 2.8. All right, here we want, what are we asked to find? We are asked to find minimum sample size. All right, so this is where we are going to have our formula, which is, I'll type it here for you, n equals our critical value times our standard deviation divided by our sample size, all squared. All right, so that is the formula that I'll be working with. All right, and move this down here. All right, what do we have here? We have a standard deviation of 2.8, a margin of error of 0.5. Remember, it's the number that follows the word within. And we want 95% confidence. To actually calculate N, we need our critical Z. We can go back to that table or calculate it in Minitab. 95% confidence corresponds to a Z of 1.96. All right, so again, that was in the lecture. All right, so we can now calculate this minimum sample size. This equals our Z times our standard deviation divided by our margin of error, all squared. All right, and we end up with 120.472576. But what do we always do here since we're calculating sample size? We always round up. And so our answer here is 121 servings of cheese. All right. How does the sample size change in number 2 if we change the confidence to 99%? All right. So if we change the confidence to 99%, that changes our critical Z to 2.575. All right. So instead of 1.96, we've got 2.575, which changes the servings of cheese to 208 servings of cheese. All right, number 4. In a random sample of 50 people, the mean body mass index, BMI, was 27.7 and the standard deviation was 6.12. Assume the body mass indices are normally distributed. Construct and interpret a 95% confidence interval. Okay, so again, we're reading the word mean, we're reading standard deviation. We know this is going to be Z or T. The question is, which one? Well, what do you think? Notice this 6.12 standard deviation is in the sentence describing the sample. We do not read the words known, assumed, past studies, population. All right, so this is going to be a T confidence interval. So we go to one sample T. We have summarized data. We have 50 people. The sample mean is 27.7. The standard deviation is 6.12. We go under options and we need our confidence on 95%. We say okay. All right, so rather easily we calculate our confidence interval, but now we need to interpret it. So with 95% confidence, we can say the mean body mass index for all people is between 25.96 and 29.44. This is, with it being BMI, we don't really have units on this, so it's okay to just report the numbers here without units because, I mean, there's none stated in the problem. All right. In a random sample of 15 mortgage institutions, the mean interest rate was 4.99% and the standard deviation was 0.36%. Assume the interest rates are normally distributed. Construct and interpret a 90% confidence interval. Again, notice the standard deviation is in the sentence describing the sample. You do not read the words known, assume, past studies, population. So again, this is a T confidence interval. We go into one sample T, summarize data. We have 15 institutions. Because of the way we're putting these numbers in the mean and standard deviation, we do not have to convert them back to decimals. We can just type 4.99. You would just omit the percent symbol. It's certainly fine to do that. And then under options, we need to change our confidence to 90%. All right, and there is our confidence interval. So with 90% confidence, we can say the mean interest rate at all mortgage institutions is between, now we want to add those percent symbols back in, 4.83% and 5.15%. Okay. Last problem. In a random sample of 13 people, the mean length of stay at a hospital was 6.3 days. The standard deviation is known to be 1.7 days. Assume the lengths of stay are normally distributed. Construct and interpret a 99% confidence interval. Again, we read mean and standard deviation, so we know this is Z or T. Which one is it? And here we pick up our keyword known. The standard deviation is known to be 1.7, so this is a Z confidence interval. So we go into one sample Z. We have summarized data. We have 13 people. The mean is 6.3. The known deviation is 1.7. And under confidence, we change our confidence to 99%. And there we have our confidence interval to interpret. So with 99% confidence, we can say the mean length of stay at the hospital for all people is between 5.09 days and 7.51 days. All right, so there's some practice with Z and T. There is also practice for you on proportion. I'm not going to do a video on the proportion problems. If you have any questions, do not hesitate to reach out to me and I'm happy to help.